approximate the error in y, approximate the exact error in y by this nice product. Instead of plugging in all this, approximate the error by this product. Okay? Two different things. So now I'm coming back to that because I haven't finished. I have one more step and then we'll go back to an example from 3.7. I have to present this before I show you 3.7 on those cost functions because it will not make any sense. Okay, so then here, coming back to this super important result, all you have to remember is this, because from here you can build it very easily. What is the exact error? F of x plus dx minus f of x. What is the differential? F prime of x dx. What I'm going to do is I'm going to move the function to the other side. I'm adding the function to both sides. So f of x plus dx is approximately f of x plus f prime of x dx. It's an important result for Calc 2. When you get to series, Taylor series, etc., etc., it's a very important result. Okay. So now, having this in mind, I want to go back to a problem that now I hope it makes sense better. Back to 3.7. With those problems with the marginal cost, etc., etc. Maybe I should do an example here before I show you that. Yes, let's do an example here before we go back to it. Okay. So I would like to pick any approximation so you see how this works. I don't know. I'm going to pick 28, the square root of 99.8. And you see the power of calculus now. So we have the square root of 99.8. Is there a way of determining this without punching in the calculator? I don't have a problem punching the calculator, and everyone has calculators. We are in a technology age, right? Why would I even bother with all this? Just to illustrate how the basic of all these calculations, basically. Because they didn't have calculators. And just to see a result and how it works in calculus. So what I have to identify, so I'm asked to find an approximation. I'm not asked to punch in the graphing calculator. I'm asked to find an approximation. And as you see, this is a linear function. This is a linear function. This is a square root. It could be anything. The square root, I can do it by hand. But if I put natural log of 1.1, I'm not going to be able to determine that by hand. Okay, so this is the question. Approximate it. Fine. But I have to determine number 1, which is the function. I have to determine number 2, which is the x in question. I have to determine number 3, which is the error, and it better be small, because the approximation will not be good. If the error is 15, that's not small. When we talked about the graph, we said Q is really close to P. So if you say that this is 15, the approximation fails. Okay, and once I identify the function x dx, then I'll determine f prime. So can anyone tell us what this is? What function are we looking at? Absolutely, there is nothing else. Thank you very much. Which means that f prime, as we know a long time ago already, is this. So we have number 1, and we have the derivative. Next, we have to identify x and the tiny error from x. Look at the number inside and say, oh, I know, x must be this, and dx must be that. What will you say x is and the tiny error from x would be?
Would x be 99.8?
I want an x and I want a tiny error. And
Is x 100 and dx is 22?
that's it. I have x, which is 100. Furthermore, I know how to take the square root of 100. And there is a minor error from 100, and that minor error is 0.2. That's all I needed. And I'm just going to put in everything and create a linear function. From a linear function, get a number. So, f of x for the x that you gave me. So this must be f of 100 plus f prime of 100 multiplied by 0.2. I continue. Of course, I ran out of room, you know that already. I have to move on to the next page. So, I'm just going to put a symbol here like this and continue here. F of 100. How much is f of 100? Very good. Plus. You already told me that f of 100 is 10, so I have 1 over 20 times 0.2. Okay, so this is 10 plus. I'll simplify. First of all, I'll multiply the top and the bottom by 10 to eliminate decimal numbers. Then I'll simplify by 2. So this is 1 over 100. So this is 1,000 plus 1. 1,001 over 100. You had no idea that this is approximately the square root of 99.8. You had no idea. So 1, and you know what that is, right? Divided by 100, I don't have to divide it, but I just wanted to show it to you here. And the square root of 99.8. Any questions? Now we are ready for that problem with the cost. And you'll see this should be a breeze now. Here is the cost problem that I prepared you for. It doesn't matter. The cost function for production of a commodity is given. I'm going to copy it in a minute. Find and interpret C prime of 100 and then compare C prime of 100 with the cost of producing the 101st item. Okay, so let's take it easy, step by step. So we have C of x, which is 339 plus 25x minus 0.09x squared and plus I think I see 3 zeros. I'm going to check. X cubed. Yes?
Is this back at 3.7 or are we still in 3.10?
So this is a problem from 3.7 that we needed preparation from 3.10. I'm going to rearrange this in the correct order. Plus 25x plus 339.
Does that say 0.0004x cubed?
Yes. I checked.
Okay.
I checked twice. I'm going to check again. Yes. 3 zeros for x cubed. So first question here is find and interpret C prime of 100. That's our first question. First of all, we have to determine what first?
C prime of x.
Thank you. This is called the marginal cost. Fine. So let's find C prime of x. I bring down 3 and I multiply by 4, so I get 0.0012x squared. I bring down 2 and I have minus 0.18x and this plus 25. So we determine the marginal cost. Now we can determine C prime of 100 and we will have to interpret and see what that means. Okay, so 0.0012 multiplied by 100 squared and then minus 0.18 multiplied by 100 and then plus 25 and I got 19. Measurement unit. Anyone? It represents the rate of change of cost per unit. It predicts the cost of the 101st dollars per unit. It predicts the cost of the 101st item. Okay, part B. This is why I needed all that theory from 3.10 so we can understand what happens here. They are asking us to compare C prime of 100 with the actual cost, with the actual exact cost of producing the 101st item. Compare C prime with the actual cost of producing the 101st item. So what I'm really saying is what I've said a few minutes ago. The actual difference in the cost, which is the cost of x plus dx minus the cost of x, is approximately C prime of x times dx. Exactly the same thing we wrote with y or f, now we write with C. So at this point we're asked to find this. We have not found the exact cost yet of producing the 101st item. How will I determine the exact delta C for item 101st? So x is 100, and how much is dx? Very good. So that's why this is 1 in our example, because they want 101 and because we are talking from 100 to 101. We already have this piece. We just calculated it. It was 19. This was the approximate cost. Difference in the cost. This is DC, the differential. The difference in the cost for if you want an error or moving on to the next item. The error is 1. We're not manufacturing 100, but we're manufacturing 101, but it's not an error this time. We just want to go one more unit. So we determine this because dx is 1 and we calculated C prime of 100, which was 19 per unit. But now we want the exact. We want to see how close the exact is to the approximation using the derivatives, using the differential. So can anyone tell us how to find delta C? It will be the cost of minus the cost of. The cost of what minus the cost of what?
101 minus 100.
Perfect. Of course. Thank you. X plus dx minus c of x. Good. So now I go back to the calculator, and I'm going to put it in y equals because it's easier for me, and it doesn't matter. I should have done that from the very beginning. So x cubed, you don't have to, just calculate 101. Minus 0.09 x squared plus 25x and plus 339. Second in table, 100, 101. So 101 was 2358.0304, that's very important, minus 2339. Okay, so what do we get? So 2/3 of 58 minus 39 is obviously 19.0304. Exact difference, exact cost of the 101st item, and this is the approximate cost. Approximate. 19 using the derivative in a blink, and 19.0304 the exact. Any questions? Any questions? Any questions? Do you feel like doing another approximation?
Yes.
Perfect.
Yes.
So there are several problems with approximations, or we can make one up. 1.999 to the fourth, e to negative 0.015. Cube root, tangent 44, 1 over 4002. You choose.
Let's do the tangent one.
Tangent 44? Perfect.
Yeah.
Tangent 44 then.